Hello, in this video we're going to take a look at the basic idea of inflation. So we're going to start with an example where let's say that we find that 25 years from now, we have an annuity that will pay $3,533.90 per month in income. So we have this large investment fund, and then we create an annuity, and that annuity will pay us out this amount of money per month. What we need to keep in mind here is that that amount is in the future, after inflation erodes the value of those dollar amounts. So because everything is getting more expensive, this $3,500 in the future will not buy in the future what $3,500 will buy today. So what we're going to do is adjust these values to see what their value is in today's dollars. In other words, what is the spending power of this amount, $3,500, if we receive it 25 years from now? So let's start with a little bit of terminology first so that it's clear what we're talking about. We talk about nominal dollars, which is an amount of money that's actually spent or accumulated, usually in the future. So sometimes we call those future dollars. We also talk about real dollars. This is the amount of money that's been adjusted for inflation, which tells us the spending power in terms of today's dollars. So essentially you have nominal dollars are sometimes called future dollars, and real dollars are sometimes called today's dollars. So we can go back and forth between these two with a simple calculation. So here's a basic formula that we're going to use. We're going to use I to be the annual rate of inflation. So let's say the inflation rate is assumed to be 3%, then I would be 3% or 0.03. Capital F is the future value of some amount. Those are the nominal dollars. So remember, future dollars are typically associated with nominal dollars. Little a is the value today. Those are the real dollars. T is the number of years in the future. So that's the number of years that inflation is acting on our money. And when we use all of these variables, we also are going to assume that inflation acts once annually. So that's sort of like saying that inflation compounds once per year. If that's the case, then we say the future amount is equal to the real amount. So capital F is equal to little a times the quantity 1 plus the inflation rate I to the power of t. Now, this looks a lot like our compound interest formula, and that's because it is. Instead of using R over K, we're just substituting that with the inflation rate I. And instead of using K times T, we're just going to use T, because K, which is the number of times that something compounds, in this case, K is 1, because we're only letting inflation act on our values annually, once per year. So we have a situation where K is 1, so K times T is just T. Okay, so let's keep going. Let's take a look at a simple example. A product costs $100 today. So we're being given today's dollars, real dollars. If the inflation rate is 2.5%, what will the cost of that item be in 30 years? So if we look at our formula for inflation, the future cost or the future value of this item is equal to the value today, little a, times 1 plus the inflation rate to the power of t. We can plug in the numbers. We have little a is the amount of, or the cost of that item today. It's $100. The inflation rate is I equals 0.025, and the value of t is 30, because we're going to look at what's happening in 30 years. So essentially what we're saying is we're looking at an item that's $100 today, and we want to know what is it going to cost in 30 years if every year it grows in value or in cost by 2.5%. And that's a simple calculation to do. It ends up being $209 and roughly 76 cents. So you can see that the cost is going to more than double of what it originally was, with a relatively low inflation rate that's allowed to act on our particular item for a total of 30 years. Now, this example simply takes us from the value today to a value in 30 years. What we really want to do is go backwards. We want to know, like we said before, let's go back here. Let's say in the future, we know we're going to get $3,533.90. The question is, what is that worth in today's dollars? So in the next video, we're going to take a look at that. But for now, this gives us an idea of how to proceed and what formula to use. And it's basically a modified version of our compound interest formula.